Good day, everyone. For this Storm of the Month video, we're going to be looking at some storms of the month from July, specifically July 18th. We didn't have a lot of really good supercells to highlight with this video series, so instead of highlighting a specific storm, I decided to go ahead and highlight a specific day, and that day is going to be July 18th. Here are the topics we're going to cover. First, we're going to look at an overview of the weather pattern leading up to the event we're going to look at. Following that, we're going to look at the satellite and radar of the event, and then we'll look at some storm reports briefly before we conclude with key points for the video that we are wanting to really drive home with this. So start out with an overview for this event. So as you can see from the 500 millibar pattern there on the right, we had an upper level ridge pretty much dominating the weather pattern for us on this day. So there is really weak flow aloft overall. SPC did note an MCV over northeast Nebraska during the morning. Now we're going to skip all the way down to the surface from 500 millibars because as I looked at 850 and 700, all three of them showed pretty much the same thing. So for simplicity's sake, we're going to go ahead and skip right down to the surface. So as you can see, there's not a whole lot going on at the surface at 12Z. There is a weak, I guess you call it, stationary front, kind of bisecting the area from north to south. Looking at the surface maps through the morning and into the early afternoon, this stationary front didn't move too much. It might have wiggled just a little bit to the east or west, but it pretty much stayed right where you see it there at 12Z. As I mentioned, 18Z, not a whole lot of change. So there is a little bit more of an eastward swing over the southern part of our area with that stationary front. So now that we've looked at kind of the overall weather pattern for the day, let's go ahead and look at some convective parameters. So on the following slides here, we're going to see animations running from 16Z to 21Z. So the first one we're going to look at is the 7 to 500 millibar lapse rates. And as you can see, they're not all that impressive, 6 to maybe 7 degrees C per kilometer. So not a really good environment from a lapse rate perspective for severe thunderstorms. And as you'll see on the satellite and radar images we have coming up, the storms actually moved from a more unstable environment down into a more stable environment as they moved into Kansas. Looking at the effective shear, that one really isn't too impressive either. 30 to maybe 40 knots at best for this event. So just strong enough to support severe thunderstorms. Nothing really spectacular with the effective shear. Looking at the mixed layer CAPE and SYN, we have a little bit better picture of what the convective environment was like. As you can see, as we go through the morning and into the early afternoon, the mixed layer CAPE does increase to about 2,000 joules. And of course, the mixed layer SYN does decrease. You notice we have this blob, so to speak, of SYN moving south into Kansas. And that is actually the models capturing that stable environment, that cold pool, if you will, behind that convective line that moves south out of Nebraska and into Kansas. Looking at the most unstable CAPE and the lifted parcel level, the lifted parcel level is going to be the image, and that's basically showing us how high does a parcel have to be before it undergoes free convection. So the higher above ground it has to be before that happens, basically the warmer the color. So as you get cooler colors and then actually the white color, that's telling you that it's becoming or is surface based. So actually about mid-morning, the parcels were already surface based, which is fairly early even for the summertime. And you notice that also coincides with the higher most unstable cape readings. So kind of what we saw on the prior slide with the mixed layer cape, as we went into the mid to late morning, the storms are already able to start tapping into that unstable environment that was becoming available as the mixed layer sin eroded, and eroded rather quickly, even for the summertime. Now we're going to now look at the satellite and radar images for the event. As you can see with this visible satellite loop, we have a nice line of storms coming in from the north and spreading across the area. And you can also see that nice arc in the clouds. That's the cold pool shooting out, if you will, from the rest of the storms there as they move south through Kansas. You notice the stable environment behind that outflow boundary. There's really not a whole lot of cloud cover once the storms themselves move on to the south and east. So that tells us right away that we're going to have a very stable environment. So once the outflow boundary moves under the storms that you see developing to the southwest of it, there's not really going to be any fuel to keep them going. I also want to direct your attention to those updrafts and eventual thunderstorms that do develop along that stationary boundary out ahead of that incoming outflow boundary. So for a little while, and you'll see this on the radar coming up, for a little while we did have two areas of storm activity before the squall line, if you will, moved out of the area, and then that outflow boundary moved through and then undercut the storm activity along the stationary front. Here is the radar imagery for the event. So as this was approaching our area from the north, we were watching, and then as it moved into Red Willow County, we noticed that there were some spotters under the strongest reflectivity. So we decided to see what was going on there because it wasn't quite severe, but we weren't really sure, how strong the storm was at the time. So we called some spotters underneath the worst of what it looked like on radar, and all we could find were heavy rain reports. So I thought, okay, so it should be subsevere. But about 15 minutes after our last call, the storm underwent a dramatic increase in intensity and growth vertically. So we decided, all right, well, it looks like it's probably severe now, so we're going to go ahead and send out our first warning of the day, which was about 9:20 in the morning Mountain Time. We send it out, and within a minute, we actually get a phone call from the Red Willow County Dispatch Center of, I believe it was $half size hail. So we continue with the warnings, as you can see, over the eastern part of the area. And then while we're doing that, we actually have another area of storm activity flare up along that stationary boundary that was roughly along Highway 27. So we had a little bit of kind of divided attention there with the semi-squall line moving south over the eastern part of the area, and the second area of storm activity over the stationary front. So unfortunately, because we were so focused on that line moving south, we really didn't message the potential for storms to develop along that stationary boundary. So the only notice people got about the weather was when we started sending out the warnings there, unfortunately. You also notice as that outflow boundary to the east moved through the storms that were developing along the stationary boundary, or stationary front, that they very quickly weakened. And that was again due to the stable air that was following the outflow boundary in. So that was something we had to keep in mind when we were issuing the warnings, was we don't want the warnings to last too long, because we don't want to have a warning going once the storm actually collapses. And they did weaken quite rapidly behind that outflow boundary as it moved through. So here are the storm reports for the day. The largest hail report for this event was 2 inches in Goodland. This report came from a left splitter. The storm actually split to the west of town. The right one moved into, I believe it was Kit Carson County, and maybe even into Cheyenne County, Colorado, before weakening. The storm that hit Goodland didn't get very far east of town before it actually weakened. And that was because the outflow boundary moving in from the east undercut it, and the storm very rapidly weakened. You notice too, looking at the hail reports, that 2 inches is by far the largest. The next closest one was produced by the same storm, and that was golf ball size. Otherwise, most of the hail reports are an inch or maybe an inch and a quarter. So having a 2-inch report come in, that was quite surprising. I was watching the intensity on radar, and MRMS was suggesting 2-inch hail. So it wasn't a complete shock, but at the same time, seeing a storm develop that rapidly over town was surprising given the environment. Looking at wind reports, we had, looks like 3. The highest wind gust I believe that we had for the event was an estimated 70 miles per hour. And you would think with that somewhat semi-line of storms coming in over the eastern part of the area that we would have more wind reports with it, but we really didn't, which was a little bit of a surprise. So it was really a hail event for the most part. So here are some key points for this video. First one being don't assume the storm threat will remain constant throughout the event. Remember, I mentioned as those storms first move into our area over Red Willow County, they were just a heavy rain threat based on spotter reports. But watching the radar, maintaining awareness of what the storm was doing, we found out that the storm was quickly intensified, so they transitioned fairly quickly from a heavy rain to a severe weather, and really specifically a large hail threat. So this point kind of dovetails into the next one about maintaining situational awareness of the environment during severe weather. And kind of bouncing back to that point, we had a transition of threat within 20 minutes from heavy rain to large hail. And because we are so focused on that first line of storm activity moving in from the north, we didn't message the potential for storm development over the stationary front ahead of that cold pool and that outflow boundary. So because we weren't staying situation aware of the environment over our area as a whole, we missed that opportunity to communicate that other area of storm development a little bit later on in the day. One thing we did do during the event is we did notice that as that outflow boundary moved through, it was very stable environment behind it. So we were able to trim our warnings a little bit more precisely as we timed in how soon that outflow boundary was going to undercut the severe storm, so we could have a fairly well-timed warning and not have to cancel it or have one kind of hanging out there with nothing really going on within the warning. Well, that's all I have today. Thank you for your time. Hopefully some of the points that were covered in this video will prove to have you better prepared for a similar severe weather event in the future. Have a great day.